Good afternoon, everyone, and welcome to the first Engage of the year. My name is Brianna Horton, and I am a Public Engagement Specialist here at Goddard Space Flight Center. My colleagues and I are happy to be back again in 2022, bringing to life these amazing missions, projects, and topics, especially in this virtual platform where we can reach more audiences. Before we begin the program, I would just like to make a few housekeeping and announcements regarding the event. First, I am happy to have our colleagues from the Maryland Space Business Roundtable here with us at the event today. It is a privilege to have such amazing partnerships with the MSBR, and we look forward to many more events in the future. Second, we will have a live question and answer session at the end of the panel today. Please place all of your questions in the chat on the right-hand side of the screen. Third, unfortunately, we are unable to do closed captioning during the event today, but closed captioning will be available in the recording after the session is over. Now that's enough of me talking, and I would like to announce and to introduce the main show today. I'm going to turn it over to Michelle Smith, the Communication Specialist for GOES-T Project, to kick off the panel today. Michelle, please take it away.
Thanks, Bree. Good afternoon, everyone. With me today are Ed Grigsby, Candace Carlisle, and Dan Lindsay, and we are very excited to talk to you today about the upcoming launch of GOES-T on March 1st from Cape Canaveral Space Force Station in Florida. First up, we have Ed Grigsby. Ed, please introduce yourself and tell us a little about your role in the GOES-R program.
Thank you, Michelle. It's great to be here today, and I'm very excited to see GOES-T launch. As Michelle said, I am the GOES-R Deputy System Program Director. My primary role is to help our System Program Director, Pam Sullivan, manage the development of the GOES-R series system and ultimately help our flight and ground projects be successful.
Thanks, Ed. So tell us a little bit about GOES-T, the mission, and the observations it'll provide.
Oh, happy. GOES-T is the third satellite in the GOES-R series, and the GOES-R is the Western Hemisphere's most advanced weather observing and environmental monitoring system. The GOES satellites provide the only persistent cloud and moisture imagery coverage of the Western Hemisphere, and that helps protect over 1 billion people who live and work in the Americas. GOES-T is the third piece of the constellation puzzle for NOAA. And over the Western Hemisphere, it will provide operational data in the GOES-West position. With GOES-T, we will have a complete GOES-R series constellation, with GOES-East, GOES-West, and an on-orbit spare that can quickly move to either the East or the West orbital position if needed. The GOES satellites provide real-time, high-resolution imagery, atmospheric measurements, and lightning mapping for more accurate weather forecasts and severe weather warnings. The GOES satellites also host a suite of enhanced solar imaging and space weather monitoring instruments. GOES-T will continue the revolutionary improvements brought on by GOES-R and GOES-S. So here's a fun fact for everybody. GOES-T is scheduled to launch on the same day that GOES-S launched in 2018, 4 years ago.
Thanks, Ed. GOES-T will be in geostationary orbit. Can you explain why that's important for weather forecasting and warning?
Oh, sure. A geostationary orbit, and for us, it's going to be roughly about 22,000 miles above the equator, sets the satellite at orbital speeds that equals the Earth's rotation. So the satellite is directly above the same point on the Earth all the time. This means the GOES satellite maintains their position and provides continuous coverage of the same area over the Earth and experience a daily cycle of sunrise, daylight, sunset, and nighttime. This persistence of observation and data collection allows forecasters to track weather conditions as they happen and provides a continuous historical record of atmospheric conditions for future analysis.
Thanks, Ed. Now, the GOES-T mission is a collaboration between NOAA and NASA. Can you talk a little bit about how the two agencies work together to deliver the mission?
NOAA and NASA have collaborated on GOES satellites since 1975. That's 47 years. The success of our partnership really lies in leveraging the strengths of both partners. The GOES-R series is a NOAA-led program, And NOAA is responsible for overall system management, funding the satellite development, managing the ground system development, and operating the satellites. NASA, with NASA Goddard Space Flight Center, oversees the development of the GOES-R series spacecraft and instruments, and NASA Goddard Space Flight Center designed and built a magnetometer instrument that will provide critical magnetic environmental data for both GOES-T and GOES-U. Our flight project team, led by Candace Carlisle, also coordinates with NASA's Launch Services Program at the Kennedy Space Center to acquire the launch vehicle for the GOES-R series launches.
Thanks, Ed. Next, we'll talk to Candace Carlisle. Candace, can you tell us a little bit about yourself and your role in the GOES-R program?
Thank you, Michelle. I'm the GOES-R series flight project manager. My project is responsible for the instruments and the satellite. It's tried but true that I always wanted to work for NASA ever since I was a child. And when I was really young, I thought I wanted to be an astronaut until I found out that I really, really didn't like roller coasters. So I majored in physics and computer science in college. And I started at Goddard in data systems and satellite control centers. But a good friend of mine told me that flight project management was the most fun you could have at Goddard. So I went into flight project management, and I've been privileged to work on Space Technology 5, Global Precipitation Measurement, and now GOES-R.
Awesome. So can you give us an idea of what exactly goes into building a satellite, testing it, preparing it for launch? I mean, there's just so many years of work goes into this and so many steps. Can you kind of take us through that?
Yes, GOES-T has been developed over several years, and I believe that folks are seeing in the background a video playing highlights of the GOES-T integration and test. At the beginning, the satellite and the instruments are built simultaneously around the country in different places. Lockheed Martin built the satellite in Littleton, Colorado. They also build two instruments, the Geostationary Lightning Mapper and the Solar Ultraviolet Imager in Palo Alto, California. L3Harris developed the Advanced Baseline Imager in Fort Wayne, Indiana, and then tested it in Rochester, New York. The University of Colorado's Laboratory for Atmospheric and Space Physics built the Extreme Ultraviolet and X-ray sensors. The Assurance Technology Corporation in Carlisle, Massachusetts built the Space Environment Institute suite. And here at Goddard, the Goddard team has built and tested the Goddard magnetometer. Every single component of the spacecraft and instruments, as well as the instruments at the instrument level as well, are thoroughly tested before being delivered to the spacecraft facility and integrated with the satellite. For example, the Goddard magnetometer was tested at the thermal vacuum and vibe facilities in Building 7 and the magnetic test site on Good Luck Road. Once the instruments are integrated to the satellite and a number of different times over the test program, there's something called a comprehensive performance test that makes sure that everything is working together the way that it should and meeting all of the requirements of what it needs to do. Then there's an environmental test program, and that's to make sure that everything will survive the harsh environment of launch and where it's going to be in space in the orbit that Ed just described. So first of all, for GOES-T at the satellite or observatory level, the first test was thermal vacuum, and that tested GOES-T and its instruments at temperatures greater than 50 degrees C or 120 degrees Fahrenheit and down to about 25 degrees C, minus 25 degrees C or minus 13 degrees Fahrenheit. Then it went into acoustic and vibration testing to simulate the stresses of launch. For example, during acoustic testing, everything was subjected to sounds over 130 decibels. There's shock testing that simulates the separation from the launch vehicle and the deployments of the solar panels. and electromagnetic interference and compatibility testing to ensure that no part of GOES-T will interfere with other parts or be interfered with by anything that it will see in its environment. Meanwhile, for the ground systems, there are end-to-end tests and mission rehearsals to ensure that the control and data processing facilities, the communications networks, and all of the people are ready for the launch.
Great. So where is GOES-T right now in the preparations for launch?
The satellite was shipped to and checked out at Astrotech in Florida, and it was encapsulated in the fairing. Just within the last 24 hours, it was transported to the Atlas V vertical integration facility where the rocket had been built up in parallel. And today, the encapsulated spacecraft in the fairing is being mated to the rocket.
Great. So really what's left is just getting the rocket out to the pad and launching it, right?
Yes, next up is the final testing, the launch rehearsals, the final readiness reviews, and the launch.
Awesome. Now we do know that a successful launch is something to celebrate, but a lot more needs to be done to get GOES-T into the proper orbit and get it ready for operations. So what will happen after GOES-T is launched, and what's next for it?
For the first 3 hours after launch, the rocket is taking GOES-T to what's called a geotransfer orbit. And about a half an hour after separation, the solar array is partially deployed, and that makes everything power positive. So then over a 3-week period, the team and the propulsion system move the satellite into its final geostationary orbit, and then it's renamed GOES-18. Now, during that same period, the solar array is fully deployed, the X-band antennas deployed, the mag boom. Fun fact, the solar array generates about 5,000 watts of power, which is about what the AC system for your home would be. During the post-launch test phase, the GOES-R mission operations support team checks out all of the instruments. For GOES-T, that test phase will start at about 89.5 degrees west, and then GOES-T will be drifted to 136.8 degrees west so that the scientists can have early use of the GOES-18 advanced baseline imager in that west location. At the end of the post-launch test, the mission operations support team hands over the spacecraft to Noaa for operations, but they continue to provide engineering support throughout the life of the mission.
Great. And when is GOES-T then expected to be operational?
The fully operational will be, whoops. It's, sorry.
Sorry, I didn't mean to ask you a question.
I had it here. It's just going to take me a minute to find it. We're actually going through a longer period because we're doing the two-phase post-launch test. The handover to Noaa is actually in October, and then the final goes west is actually January of 2023.
Thanks, Candace. Now we'll talk to Dan Lindsay with Noaa. And Dan, can you introduce yourself and tell us your role in the mission?
Sure. Thanks, Michelle. My name is Dan Lindsay. I work for Noaa, and as Ed mentioned earlier, this is a partnership project between Noaa and NASA. And of course, Ed and Candace working for NASA, myself and others working for Noaa is just a good example of how we all work together. My job is the program scientist. So Ed and Candace talked a lot about the program, building the instruments, launching the instruments into space. My job is sort of to lead how that data is used. So we're now taking the observations, sending them back to the Earth. What is that data used for? So before I get into that, I did want to provide a quick fact about myself. That was something Michelle suggested. So I grew up in North Georgia. And I became interested in meteorology because back in the early 90s, when I was in high school, in 1993, there was something called the Storm of the Century. This was, many of you who lived on the East Coast probably remember that. It was a big snowstorm. We received 16 inches of snow in my town in North Georgia. That doesn't sound like a lot for people in, say, even Maryland, but for Georgia, that's a tremendous amount of snow. And I thought it was the most exciting thing of all time. You know, we had no power or water for a week. That didn't bother me at all. My family didn't necessarily agree with that, but I thought it was great as a high schooler. And then the following year, 1994, there was a tornado outbreak known as the Palm Sunday tornadoes. Ended up resulting in 9 fatalities in my home county. So a much more serious note, that was a terrible event, and it really made me want to get interested in weather. I really didn't get into satellites until grad school.
Thanks, Dan. So can you tell us about NOAA's role in the GOES-T mission and how NOAA and the National Weather Service will use GOES-18 data?
Absolutely. So NOAA's role is to operate the satellites and also to use the data for issuing weather forecasts and warnings. This is done in a number of different ways. One way, data from the advanced baseline imager, the imagery itself, the forecasters look at that and they make decisions based on things like the storm tracks that they see in the imagery. They can see clouds. I mean, the primary goal of the ABI is really to identify clouds versus clear sky. So they can track clouds, they can look at thunderstorms that are forming, etc. One other thing we can do, since we're in geo, is we're able to take an image every 10 minutes. And when you do that, you can actually track a cloud moving. You can think of it as basically a time lapse of the cloud, and you can calculate its motion. That will give you an estimate of the winds, and then you do an estimate of the cloud height. And so you basically have an estimate of how strong the winds are at various levels in the atmosphere. That data is then provided as input to numerical weather forecast models. And so in turn, you give this information to the models, and the models then make a better forecast. This is especially important over the Eastern Pacific Ocean, which is where GOES West will be looking, because that is an area where we do not have weather balloons. We really need a land area to launch weather balloons and collect this wind data. And so it's very important to be able to estimate the winds from the GOES satellites. One other thing I'll mention is fire and smoke. Our advanced baseline imager excels at detecting hotspots from wildfires. As we all know, wildfires have made have been a big story out west, especially over the last few years. This is also true over Alaska, which we can see. There's large fires up there. So we can detect the hotspots and then alert the firefighters where the hotspots are, and then they can deploy. And sometimes they're able to actually put out the fires quickly before they get out of control.
Thanks, Dan, for highlighting the critical data that GOES-18 provides that we all benefit from every day. And you did start talking a little bit about this, but once GOES-18 is operational, it'll be in what's called the GOES West position. Can you kind of explain what that is and why, and kind of what area that GOES-T will look over and why that's important?
Absolutely. So NOAA's operational geostationary satellites there's 2 of them that are operational at any given time. One of them is GOES East. It's centered over the east coast of the US roughly. The other one is GOES West, which is what GOES-T to become GOES-18, where that one will be placed. That's centered at, as Candace said, initially at 136.8 west, but right around 137 west, which if you don't know the longitude, that's over the East Pacific Ocean. Provides a very good view of the western US, Alaska, Hawaii, and really a large portion of the East Pacific Ocean. In terms of the full field of view of the ABI, it can actually see all the way from the east coast of the US on the eastern limb, all the way out to even the eastern coast of Australia. So it's a really massive field of view if you take the full disk view, even though it's on the limb on those extreme areas. Let's see. So some other key features that are monitored that I don't think I've mentioned yet. One thing is there's something called an atmospheric river. These do make headlines a couple of times a year, generally during the wintertime. And what this is sort of a feed of moisture in the atmosphere at the mid and upper levels especially that comes in from the tropics and the subtropics into the western US. There's a lot of terrain on the western coast of the US, mountains, etc. And so when the winds impact that terrain, it forces the air up, produces heavy rain and heavy snow in the mountains. And so the GOES West satellite is in a key position for monitoring these so-called atmospheric river events as they come on shore.
Great. So since GOES-T is the third satellite in the GOES-R series, we've been able to see just how much the GOES-R satellites have improved observations from geostationary orbit. Is there anything else you'd like to talk about some of those improvements, or maybe something unexpected or surprising we saw from the GOES-R satellites?
Sure. Yeah. So one instrument that I haven't talked about in terms of the observations yet that we did not have previously is the Geostationary Lightning Mapper, or the GLM. This is an optical instrument that keeps constant watch over in the east and west position over a really large area. And what it's doing is it is measuring reflected sunlight at 777 nanometers, which is still in the visible range. But the algorithm, for the instrument itself, is able to extract the lightning signal from that. So it's sort of a brief flash of lightning then shows up in the GLM. And what this tells us is where is lightning occurring within the domain at any given time. This is important for a number of different applications. If you've ever taken a flight from, say, the Western US across to East Asia, you do go up over the generally Southern Alaska, Aleutian Islands area. And there are thunderstorms up there, especially during the summertime. We do get some convection. And so the lightning mapper can tell the pilots where the thunderstorms are. And obviously, that's not something you want to fly through. So this would allow the pilots to then steer clear and go around the storms. One other hazard that I haven't mentioned that we're able to monitor very well with the ABI is volcanic ash. We do have volcanoes, especially in the Aleutian Island area of Alaska. I was talking about the flight path in that area just a minute ago. The volcanic ash is able to be detected by the high spectral resolution of the ABI. And volcanic ash is very hazardous for airplanes. You don't want to fly a plane into ash because it can damage the engines, which is clearly a problem. So anytime there's a big eruption, forecasters use data from the GOES West satellite, the ABI especially, to route planes around the ash and try to avoid it. The last thing I want to mention is space weather. And so we are now ramping up in terms of the solar cycle. There was a solar minimum in about 2020, and we're ramping up toward an expected solar maximum around 2025. At that time, we expect more solar storms, more solar flares, more coronal mass ejections. And so several of our instruments that Candace talked about earlier are designed specifically for monitoring those solar storms. One of them is called SUVI. In the animations, which I think you're seeing now, there's a couple of movies from SUVI where you're actually looking at the sun and you can see these sort of eruptions that happen on the sun. As a matter of fact, one happened 2 days ago. This was a coronal mass ejection. I don't think that movie made it into the videos that you're looking at, but you can find it on social media if you look around. I don't think that particular coronal mass ejection was sort of directed in the direction of the Earth, although I'm not 100% sure. That's something I would need to check on. So those are just a few smattering of the things that you can do with the instruments and the data from the instruments on GOES-18, GOES-T.
Great. Wow, that's a lot. So I think we're about ready to wrap up our discussion. Thanks Ed and Candace and Dan for talking to us. And I know I'm really looking forward to seeing GOES-T launch on March 1st. So I will hand it over to Marissa for some questions from the audience.
Great. Thank you very much, Michelle. And it's great to be with all of you. It's very exciting to hear about this opportunity and this launch, because I know we're all very familiar with weather. Everybody is affected by weather. And so it's great to hear from all of you. So the first question I have is, how important is the GOES series to the Earth monitoring systems?
I can take that one if you'd like. So I would say that the Earth monitoring from geostationary satellite is extremely critical. I think what it fills the role of when we need low latency data, we need to know it very quickly, and we need to monitor it constantly. I don't think I mentioned hurricanes yet. That's one example. Is hurricanes can spin up rather quickly. So once they do, we need to be able to pinpoint where the hurricanes are located, and then track them with time. And that information is fed into models, which then numerical models, which forecast where the hurricanes are going to go. Goes west, there are hurricanes in the East Pacific Ocean. They're not only in the Atlantic, and sometimes they do threaten Hawaii. So goes west is in a nice position to do that. I hope that I answered the question as the asker intended, but if I didn't, they can maybe clarify exactly what it is that they're what they're looking for.
Great, thank you so much. Our next question is, how far north and south does GOES view?
I can take that one again. So in terms of the ABI, the primary imaging instrument, it does see the full disk and the full hemisphere, really. But in terms of usable data, I would say if you look on the north end, north of Alaska into the Bering Sea, you can see features in the visible channel, which is a 500-meter resolution at subpoint. You can see features like ice, including like breaking up and coming together sea ice in the Arctic Ocean. So that's north of Barrow, Alaska. We're talking around 70 degrees north or so. If you go any further north than that, then it gets really, really blurry because you're sort of looking at it at an extreme angle. And then on the southern end, you can see down to around the coast of Antarctica, something like that. So I'm going to say usable data from about 70 north to 70 south, although the resolution is better near the equator.
Thank you very much for that. Okay, here's a different one. After the upcoming GOES-T launch, we know that there is a GOES-U planned, which is the last spacecraft of the GOES-R series. Are plans in development for the next generation of GOES weather observatories?
I'll take that one.
Excellent.
There is a program in formulation right now, GeoXO. GeoXO is the follow-on to the GOES-R series, and that satellite system will be in the 2030s through the 2050s. A first launch is scheduled somewhere in around 2032 to 2034 right now, and it will continue with enhanced imaging and multiple instruments, including right now our baseline includes ocean monitoring, atmospheric composition observations, infrared sounding, and an advanced lightning mapper, including also an imager in both east and west position that will advance the state of the art even further than we have right now.
Great, thank you.
You're welcome.
Looking past GOES, how does NASA's Earth System Observatory plan impact NOAA's GeoXO planning? Are there opportunities for the government to realize synergies?
I guess I'll take that one too.
Sure.
The GOES-R informed the GeoXO plans substantially. We have obviously used the observations from GOES-R to start off with planning the GeoXO, the next generation. And the second part of that question was synergies. I'm sorry, can you repeat that, please?
Sure, absolutely. Can you briefly talk about the differences? I'm sorry, I've just lost it. Hang on one second.
I know that next question will be Dan's, so.
Right? Yeah, there's a lot of questions. Talk about the differences in purposes and coverage of GOES-T versus the JPSS fleet.
Oh yeah, that's Dan's question for sure. But there is synergies between NOAA and NASA to completely help with the GeoXO formulation. Dan, next question.
Yeah, and just to add on to what Ed said on that question, one example is I believe that a NASA Earth Ventures program is going to be launching an instrument called TEMPO, which is an atmospheric composition instrument, and maybe a year, one or 2 years from now, I don't remember the exact launch date. That instrument will be very useful for NOAA to study for the atmospheric composition instrument for GeoXO that Ed mentioned. So that's just one example, I think, of synergy and how the data from NASA is used to help NOAA. In terms of the question about GOES-T versus the JPSS fleet. So JPSS fleet, if you're not familiar, is a polar orbiting program, and we have currently JPSS-1, which became NOAA 20, is operational. It has a number of different instruments. It does have an imager called VIIRS. It has a microwave instrument called ATMS. And so one way that they differ is microwave is something that we are not able to do from GEO, or at least we have not done it yet from GEO. I'll say it that way. And microwave is useful because we're able to, it's longer wavelengths and we can often see through clouds. And so one example of how microwave imagery is used is with a hurricane. It's very cloudy. You can see in the microwave data, you can see beneath the cloud deck and look down into the precipitation occurring within the hurricane itself. And so that's one way that that's one observation that JPSS takes that we do not have from GEO. GEO, we've described the GOES-T observations pretty well. The big advantage, in my opinion, of GEO over JPSS is there's two advantages. Number one is the latency. We get the data within minutes of when the observations are taken. And the second one is the refresh. The fact that we are at GEO allows us to constantly watch. And so with JPSS, you get a snapshot and then it's gone. With GEO, you're getting movies. You're able to watch things move in real time.
Great, thank you, Dan. So here's one that's a recent event. So 2 months ago, the Marshall Fire in Louisville, Colorado, destroyed about 500 homes. Apparently, a 100-mile-an-hour wind from the Rockies initiated this event. So the question is a friendly one. To provide faster evacuation warnings, does GOES-T have the capability of detecting Rocky Mountain winds and/or other high wind meteorological scenarios originating in the Rocky Mountains?
I can take that one. So the satellite technology, we can't necessarily detect the windstorms themselves. Sometimes what we can do is, and I mentioned this earlier, is we can track clouds and then if there are clouds present, and then extract the wind data from that. But we don't actually track, I guess in the clear sky situation, we don't actually see the winds. What we can do though, with regard to fire detection is, and this is where you would use data from, say, a numerical model forecasting high winds. We would use the data from GOES-T to detect, say, a new fire start. And then in the situation where we know that the winds are going to begin blowing or they're already blowing, the relative humidity is low, it's very dry, that would be a very dangerous situation if you get a fire start in that sort of weather condition. So it's really, I would say, data used in concert. We'd use the observational data from GOES-T to detect the fire, and then observations from the surface and from numerical models to predict the winds and, say, dry air. And all this information combined is then used by say, firefighters and emergency managers.
Great. So here's one for all of you. I think we should start with Candace. What is the one thing you are most excited about for this mission?
I think it's really cool to see the GOES data. There's a couple websites where if you follow, just Google NOAA GOES data, and you can find these really cool loops that show you the things like hurricanes, can show you fires and how they're spreading, and storms and lightning. And so you can really see, from a big picture, how the weather in the whole Western Hemisphere is working, and really interesting phenomena. So that, to me, is the coolest thing.
Dan, what about you?
Oh, it's so hard to say. So I'm excited about being able to continue the GOES West mission. And, with GOES 18, it'll be able to continue, many years into the future. There's a number of research projects that are ongoing now that are relatively new, and so they may be somewhat immature. I think in a few more years, they'll become more mature and then may result in some exciting things that would then go into operations. One example, just really quickly here, is there's some projects that use ABI and GLM data and machine learning to combine that information together to simulate what a radar image would look like. And then that data, and that's especially useful over areas where we don't already have ground-based radar. So we have ground-based radar generally over the continental US, but out over the ocean, we don't. And so this data can be used to basically tell forecasters and people that are, say, ship captains where dangerous thunderstorms are located. It can also be fed into models. So I guess what I'm most excited about is continuing to learn from the data. And GOES 18 will provide us, that continuous coverage and long-term monitoring from all of its instruments.
Great. And Mr. Grigsby, what about you?
Well, how can I follow those two answers? Awesomely cool data, and yes, we're going to have scientific discovery in the future. Yes, I think the data looks tremendously cool. Every time I see one of the pictures of the videos, it is tremendously cool. And yes, I got into this business with NASA in the science mission. And science discovery has always been something I've been extremely interested in. The secrets of the entire Earth observing this Earth system is contained in the spectrum. And we measure that spectrum. And we don't know what people are going to discover in the future. We have no idea. There's going to be some scientist and Dan's mid-career, late career that comes up with some unique observation and some unique understanding of the Earth's system that is going to really impact our children and our grandchildren. Every single day, we impact over 1 billion people's lives.
That's an amazing fact.
Can't say anything better than that.
Absolutely. Well, what about, let's flip it around. What are you most worried about?
What am I most worried about? I worry about the unknown things. I think we, Candace and her team have done an outstanding job making sure that the observatory is ready, the instruments are ready. Our ground system management and implementers have done a great job making sure the groundwork, Stan and the entire science teams know how to use the data, but there are things out there that we just don't know. I think the coronal mass ejection that Dan talked about earlier, something like that could happen, and we wouldn't know. We wouldn't have any idea it was coming. So that's what I worry about, are the unknowns.
Candace, what about you?
Well, space is hard. As I was just describing, we very, very thoroughly test everything. And we are going up on an Atlas rocket, which is really, really highly reliable, has a tremendous success record. But still, there are occasions when things fail in space. So you betcha during that 3-hour coast phase, I'll be, sitting there waiting to see the spacecraft successfully deploy and talk to us. And then during that 3-week orbit raising period, every day, I'll be making sure everything went well. And during that, multi-month checkout period, every day we'll be making sure that everything works correctly. We've built everything really carefully. We've tested it really carefully. Everything's built to a very high reliability requirement, but still there are things that can go wrong. So for the next few days, weeks, and months, we'll be watching everything really carefully and, having faith in all the work we did, but also, with some degree of, hoping that everything goes well.
Fingers, toes, and everything crossed, right? How does the GOES satellites work with those from NOAA's international partners?
I can take that if you'd like. So in a number of ways, really. Data sharing is one way. So even though we cover, the GOES covers the Western Hemisphere, the data collected over the Western Hemisphere impacts the forecast for the entire world. So there's such thing called global models. Those are models that are run all over the entire Earth. And there's a number of different agencies that run global models, including the U.S. National Weather Service, but also Europe. There's the model called the ECMWF. That's one of the models. And they take data, as an example, from GOES East and GOES West and feed it into their models. And then weather systems that are over the US or over the Atlantic or moving into Europe, they collect valuable data for that, which then improves the forecast for their models and for Europe. So it's really a nice collaborative effort by the entire world. I mentioned Europe. There's also East Asia. We have very good relationship with a number of agencies there, and really the rest of the world too. So there's lots of different ways that we do collaborate with our international partners.
And speaking of the launch, where will you be watching the launch from, all of you?
I think we're all going to be at Kennedy.
So, but at different places at Kennedy.
That's
I'll
right.
be in the Mission Directors Center. So on behalf of the spacecraft, I'm actually the one that has the go call. I'll be sitting in the same place with folks from Kennedy Space Center, folks from the United Launch Alliance, and folks from Lockheed Martin. And we're all involved in saying everything's okay and we're good to go.
That's going to be very exciting.
Yes,
And I'll be listening to Candace do that.
And Dan, presumably you'll be here as well, Florida?
Yeah, I'm planning to be probably the same place as Ed, watching the launch from there. So I'm excited about that.
That's great. And for people that are not going to be fortunate enough to be at the Kennedy Space Center, they will be able to watch it live, correct? And that will be broadcast at 4 p.m. Eastern on March 1st. And the launch window opens at 4:38 p.m.
Absolutely.
So if you can't get to Florida, make sure you're watching it on your computer or your tablet or phone or something, right?
Absolutely.
Great. I don't have any other questions. If anybody else has some questions out there, please, by all means, let us know. Otherwise, I will turn it over to you, Ms. Bree.
Thank you so much. And thank you, everyone, for your time today. It's really a great partnership between NASA and NOAA, and we're very excited to see the GOES satellite launch on March 1st, fingers crossed, from KSC. We enjoyed having the panel here today, and please stay tuned for the next announcement for the Engage series. We're going to try to keep it on the third Thursday of every month at this time at 1:00 p.m. Thank you, guys.
Thank you. Go, T.